we finally reached the point where we can work with the translations of the trig graphs. So our objective for this lesson is to be able to translate the trig graphs. The model we'll use for this lesson will be sine. It does work with the other trig functions as well, and we'll work with degrees here, though it does also work with radians. Now the big idea here is, as a reminder, this works just like our other families of functions. If you have a number outside of the trig function that's being added or subtracted, that translates the whole graph up or down. If it's a number that's positive, it translates it up. If it's a number that's negative, it translates it down. Whereas if the number is on the inside of the trig function, so inside of parentheses here, that's going to horizontally translate the graph, and it does it in the opposite direction. So if you have it minus a number, it's going to translate it to the right, and if it's plus a number, it translates it to the left. That's because that would be back to where the original 0 would be if we would put a number in for x. So let's take a look at these piece by piece, and then we'll combine them together. So on this one, if we look at the number on the outside, this is a vertical translation. And we'll call it also vertical shift. So I'm going to use both words, translation and shift. Both are used in these contexts. A vertical shift means we're going to take and move it up or down. So with a graph like this, we're going to take that 3 and move the midline up from the x-axis up 3 units. So we'll start with the midline. So I'm going to go up to 3 units here, and I'm going to draw a new midline here with a dotted graph. It's not an asymptote, it's just a reference point for where the new midline is. And then I'm used to the fact that sine goes 1 unit above the midline and 1 unit below. So I'm going to go up to 4 and down to 2 on this graph. Now our x-axis, we're going to mark off the key points to graph. They're the same as before. We still go out to 360 degrees for one period. Split that in half and you get 180. Split that in half, you get 90 degrees. Split that between those two and you get 270. Now when we draw our graph, we're going to draw the graph by starting the sine starts on the midline. The new midline, remember, is now translated up 3 units. So I start there, go to the top point at 4, back to the midline, down to the bottom point, which is now at 2, back to the midline. So my graph would look like this. Notice that's my sine graph that's been translated up 3 units, according to my vertical shift. Now, if we work with this one, this has a number on the inside. This is a horizontal shift on it, or we call this a phase shift. I'm going to use that phrase because that's the common phrase we use. Phase shift is where we work with it horizontally, and also it's in the opposite direction. That's very consistent with the other families of functions that we've done. So the phase shift, if I look at a problem like this, you would expect a minus 100 would be in the negative direction, but because it's in the inside, if I put 100 in for x, that would take me back to my original 0. 100 minus 100 would be 0. That's what I'm interested in. What would give me 0 if I put it in for x? So that's why it moves it out of positive 100 degrees. So if I mark 100 degrees here, now I've got to do my period. Now my midline is still going to be the x-axis here because I haven't shifted it vertically. So 100 degrees here, I'm going to move out a full period past that, add 100 onto 360, and I go out to 460. And now I've got to start averaging these. And so what I'm going to do is to average these two and average them after that. You go ahead and add these two together, you get 560 when you add those together, and if you divide that by 2, you get 280. Now if I add these two together, I get 380, and then when I take half of that, I get 190. Notice I'm going by 90 degrees. So that's the other way that you could tell, is if you remember that each key point was 90 degrees, I just add on 90s then, and I get my key points for this. So it's either take and average them to get the middle points, or you could know by dividing by 4, the period by 4, how many you're going to add on each time. Now, this one will go up to, when we do this, it goes up to 1 and down to -1, just like before. We go above and below the midline. And so I start now my period at this new horizontally shifted starting point. So start there, go to the top, to the middle, to the bottom, and then back to the middle. There's my sine graph of one period with the new horizontally shifted key points. Now what we want to do is put all of that together. When we look at our graphing formula, what do all of these numbers do? Well, this first number, just as a reminder, this first number is a vertical shift, or translation, if you want to use either phrase, translation or shift. This number in front, remember, this affects the amplitude. Now the amplitude, remember, goes from the midline. So if we vertically shift the midline, that amplitude goes above and below that midline, but it's still the distance from the midline to the top point for our amplitude. This number here, which has to be, by the way, factored out. You don't want to have a number in front of the x. If there is, you factor out of it, so you have it distributed out like this. This is affects the period. Okay, and how it affects the period, remember, is that you take the normal period and divide by that b, and you get the new period. So that's either going to be 360 divided by b, as we're using degrees, or it's going to be 2 pi divided by b, or if it's tangent, remember why it affects period, tangent and cotangent, their periods are down to 180. So if it's tangent, it'd be 180 divided by b or pi divided by b. Okay, but I'm using sine as my model here, so I'll use those two. Then on the inside, this is my phase shift. So my phase shift, if you recall here, as we just talked about, is in the opposite direction. And that's going to be important to recognize that if you factor out this b, then you'll know what the phase shift is. If that b is still in there, then you would not have the correct phase shift for it. All right, so now that's what the formula does and each of the parts do. Let's go ahead and do some examples here. We're going to use sine, cosine, and we'll do a tangent problem as well. So we're going to do one period here in degrees. So if I look at this, remember this is my vertical translation, so I'm going to go ahead and mark off 4 units. -4 down here. That's my new horizontally shifted midline, so I'll draw that in. And then I'm going to go here and make sure I factor out this 3. So I'm going to have y equals -4 plus 2 times the sine of 3 times x minus 10 degrees. So this is a degree there. And then if you notice, that marks where my new starting point is. If you use 30 degrees as your starting point, it would be incorrect. The new starting point has to be when you factor out that 3. So I'm going to start my graph at 10 degrees here. And so that's going to be the new starting point. This period, let's go ahead and look at our, our amplitude is going to go up. I like to mark where the top point and the bottom point will be. So to go from -4 here, I'm going to go up 2 units, up to -2, and then down 2 units, down to -6. That's going to be the top and bottom of my graph, still 2 units, notice above and below the midline. Now, this number here affects the period, so the period will be equal to, I'm going to take 360, since I'm doing degrees, divided by that 3, that's going to give me 120 degrees. So starting at this 10 degrees, I'm going to go out 120 degrees from there, which will get me to 130 degrees. Okay, now I'm going to split that in half. I'm going to go halfway between those two. I add them together, I get 140. Split that in half, I get 70 degrees. Split these two in half. Okay, these added together is 80. Split in half is going to be 40 degrees. And then 70 plus 130 is equal to 200. Split in half, I get 100 degrees for that. So those are my key points. Now to graph it, my sine graph is going to start on the midline here at the new starting point, which has been shifted down and shifted over. And I'm going to go up to the top point at the next key point, to the middle, to the bottom at the next key point, and then back to the middle. So here is one period that goes up to -2, down to -6, shifted over 10 units with a midline at -4 using this information on the graph. Now, it also works for cosine. So let's go ahead and do the same type of process with cosine. Remember, this 1 means it shifts up 1 unit. And so the 3 tells me that and there's nothing to factor out. Notice there's no number in front of the x. So just like here, there's a number in front of the x that we want to factor out. This one has no number in front of the x, so it's in good shape for what our horizontal shift is going to be. So this one, I'm going to go up 3 units. So 1, 2, 3, up to 4. And I'm going to go down 3 units, down to 0, -1, -2. So I go 3 units above the new midline and 3 units below it. Now this x plus 60 means I'm going to start at -60, the phase shift. I'll actually use that phrase here just so we see what this means. The phase shift is -60 degrees. I'll put that right here because it's the opposite of what that number is. So here, I'm going to start out here at -60 degrees. So now I've got the information. I want to lay off my key points. So I'm going to start with my phase shift out here at -60 degrees. And I'm going to go and lay out one full period, which will take me out to 300 degrees if I add that on. So 300 degrees would be out here. And then I split that in half. If I take -60 plus 300, add them together, I get 120 when I divide it in 2, because I get 240. Now here you got to be careful. Notice that between these two, I've got to add these together, I get 60. When I split it in half, I get a 30 degrees here. Got to make sure you mark this one, because I've gone in the negative direction to start it, in the proper place. Now these two are a little too close together maybe, so what I might do here is I might move the -60 over just a little bit, just to reflect where it should be. So sometimes you have to adjust a little bit, just so that I've got it respecting kind of equal units between these key points. All right, now that I've got my key points, and this one, if I add these two together, I get 420. If I divide that in half, I get 210 degrees, okay? Which is 90 degrees for each of these. Now, let's go ahead and draw our graph. So we start our graph here. For cosine, we start up at the top of the amplitude. So I'm going to start my key point up here at 4. The next one will go through the midline at 30 degrees. Then I go down to the bottom point at 120, then through the midline again, and then up to the top point here. So my graph will look like this when I get one full period of cosine. Notice that it goes above and below the axis because my new midline has been moved up, but I've expanded my amplitude, and I've also shifted things over to the left. All right, so I've seen both vertical and horizontal shifts on these two, sine and cosine. Let's see what that looks like now with tangent. So if we're working with a tangent graph, if you recall, when we do a tangent graph, we usually do one asymptote to the left of the starting point and one asymptote to the right to get a full period in. So I'm going to first of all start with my shifts here. So this one I'm going to take and shift it down 5 units. So -5 here. Now I could draw a midline here. I don't necessarily need to because the graph's just going to go through it. Just to be consistent, I'll draw in a midline here where the graph goes to. Then back up here, I'm going to shift my graph over a positive 120 units, 120 degrees. And then from there, remember that the period, now there's no change here in period, so the period for tangent in this case is going to equal 180 degrees. Okay, so if there was a number in front here, we would have to go ahead and divide by it. But since it's 180 degrees, I want to go 90 degrees behind it and 90 degrees ahead of it in order to get my asymptotes for this. So 90 degrees back this way would take me back to 30 degrees. And 90 degrees out this direction will get me to 210 degrees. And then I draw my asymptotes there. And now remember that tangent kind of slopes up into the new midpoint here where that 120 was shifted over to. So I'm going to keep that as kind of an anchor point, and then I'm going to have it come up like this to get my tangent shape for it. So this would get me shifted over 120 degrees to get that middle point there, and then I've got my asymptotes on both sides of it, and it's been shifted down 5 units according to this information. So for this lesson, we've added in translations to the graphs. Vertical shifts up and down and horizontal shifts side to side. And then we can do all of the trig functions using that information from those new starting points.